Welcome to section 7.2, and we're going to be talking about the different properties of logs today. And we're also going to be talking about how to expand and condense logarithmic expressions. Now, the first thing is the definition of logs, and that's how we can rewrite from logarithmic to exponential form and vice versa. So remember, log base m of a equals n. You can rewrite that m to the n equals a using that swirl. And vice versa. You can also take it from exponential and go to logarithmic. M, log base m of a equals n. The product property, log base b of m times n. When we're multiplying those numbers, m and n, when we split them up, it could be log base b of m plus the log base b of n. The quotient property, log base b of m over n. Product we add, quotient we subtract. So it's log base b of m in the numerator minus the log base b of n in that denominator. In the power property we did mention already, the exponent goes in the front and becomes a coefficient. Inverse relationships, we'll see that again a little bit later on, not in this video, but remember the inverse of log is exponential. And the inverse of exponential is log. When you have the base of the log and the base of the exponential being the same, they cancel each other out. Base of the exponential, base of log, they cancel each other out. Now we're going to talk about expanding first. And when we expand, we go in the order of applying the quotient property, if there's a fraction, then product, and then finally the power property. So for number one, we don't have any fractions, so there's no quotient property. So each now product property, each factor gets its own log base 3. Log base 3 of 27, log base 3 of x, and the log base 3 of y squared. Now, each factor has its own log base 3. We added because it's all multiplication. And now the coefficient is from the exponent. So it's the log base 3 of 27 plus the log base 3 of x plus 2 times the log base 3 of y. Now looking at this, I see something. 27. 27 is the same as 3 to the third power. So we have here is actually log base 3 of 3 to the third plus the log base 3 of x plus 2 times the log base 3 of y. Now we can't always do this, but if you notice, log base 3 of 3, they cancel each other out. The log base 3 of 27, that's just 3. 3 plus the log base 3 of x plus 2 times the log base 3 of y. So when you have a constant, look to see, can you rewrite that constant? Number 2, once again, there's no fractions with our log, so use our product property. Log base 5 of x to the 1/2 plus the log base 5 of y to the third. There's our product property. Now for the power property, the exponents just slide out front and become coefficients. 1/2 log base 5 of x plus 3 log base 5 of y. Now, problem number 3. This one does have a fraction. 5y cubed is in the denominator. Now, what I do for these, everything here, every factor is going to get its own log. So there's 1, 2, 3, 4 factors. So 4 log base 7s. Log base 7 of 3, log base 7 of x squared. I'll come back and put signs in a minute. Log base 7 of 5, log base 7 of y cubed. Anything that's in the numerator is positive. You put a positive in front. We don't need a sign in front of the log base 7. It's positive. X squared is in the numerator, that gets a plus. Now the 5 is in the denominator, so I put a negative in front of log base 7 of 5. The y cubed is in the denominator, so I put a negative in front of that one as well. Now we did our product and quotient all at the same time. Now we do our power property. No exponent, so it's just log base 7 of 3. 2 goes out front, so plus 2 log base 7 of x. No exponent, so minus the log base 7 of 5. Exponent goes out front, minus 3 log base 7 of y. And there we go. I can't rewrite 3, and I can't rewrite 5, so that one is done. Now, for problem number 4, we have that cube root. I don't really want that cube root. That cube root is the same as raising to the 1/3 log of the quantity of 8y squared. 8y squared, all raised to the 1/3. So it's the log of, I'm going to distribute that exponent. 8 to the 1/3, y squared to the 1/3. So you multiply those exponents. So log, now 8 to the 1/3, the cube root of 8 is 2 times y to the 2/3. That was all rewriting. So we don't have any division, so we can go right to the product property. Log of 2 plus the log of y to the 2/3. And now move your coefficients, or exponents to your coefficient. Log of 2 plus 2/3 log of y. And keep in mind, since there's no base shown, this is log base 10. Now, on the next page, we're going to be condensing, and we just go the opposite way. We go power first, so any coefficient becomes an exponent, product, and quotient. So looking at this, I have my coefficient, so it becomes an exponent. So it's the log of x plus the log of y squared plus the log of 12. Now, what I do, we want to write just one log. Since everything here is added, it's all multiplication. So they're all in the same numerator. So I'm going to put 12 out front. Well, actually, x y squared times 12. And we would commonly write that as log of 12xy squared. Remember, there's no base shown, so this is log base 10. Same thing here. Put those coefficients to be exponents. Log 6 plus log of 2 squared minus the log of 3. So now, what we have here is log 6 times 2 squared. And you see how the log of 3 is being subtracted? That just goes in the denominator. Now, we can clean this up a little bit more. This is the same as the log 6 times 2 squared, which is 4 over 3. Now, 6 times 4 divided by 3 is 8. So all this just becomes the log of 8. No base shown. The base is 10. Now for number 11, see how there's that 2 in front? I'm going to distribute the 2. So it's 2 log base 3 of 7 minus 2 log base 3 of y plus the log base 3 of x minus the log base 3 of 2. Now, any coefficient becomes an exponent. So it's the log base 3 of 7 squared minus the log base 3 of y squared plus the log base 3 of x minus the log base 3 of 2. Now, 7 squared is the same as 49. So it's really the log base 3 of 49 minus the log base 3 of y squared plus the log base 3 of x minus the log base 3 of 2. Now, what I would do here is I'd write 1 log base 3. Since we have positive and negative signs here, I'm going to put my fraction bar. Anything that has a positive in front goes in the numerator. Anything with a negative front, it goes in the denominator. Since that's a positive, the 49 goes in the numerator. Since for the y squared, you see there's a negative in front, y squared in the denominator. Positive in front of the log base 3 of x, so the x goes on top. Negative in front of the log base 3 of 2, so the 2 goes on the bottom. Now, we wouldn't leave it like that. It would be the log base 3 of 49x over 2y squared. And there we go. Problem number 12. Once again, distribute that 3. 3 log base 4 of 20 minus 3 log base 4 of 5. Now, anything that's in front, the coefficient becomes an exponent. So it's the log base 4 of 20 to the third minus the log base 4 of 5 to the third. Now, 20 to the third is a big number. It's 8,000. So it's the log base 4 of 8,000 minus the log base 4 of 125. That's 5 cubed. So what we have here, since there is just subtraction, write your 1 log base 4. The 800 is positive. It stays in the numerator. For the negative, log base 4 of 125, the 125 goes in the denominator. So what we end up with is the log base 4 of, and 800 divided by 125 is 64. Since we have that coefficient, let's think about it. 64 is the same as 4 to the third power. So I could rewrite this as the log base 4, and instead of 64, it's 4 to the third. You see how the log of the base and the base of the exponential are the same? They undo each other. So all of that, and we end up with just 3. There's a couple of different ways to do that one. It'll all get you to the same answer of 3. That's expanding and condensing. Next video, we're going to be talking about solving again. All right, thank you, and I will see you in the next one.